ISA Firewalls Part 2, Packet and Application Filters. The goal of this nugget is to round out your knowledge of the firewall capabilities of ISA Server. We're going to start that off by picking up where we left off in ISA Server Firewalls Part 1, configuring the packet filtering and IP routing features. We'll then get into the ISA server and start setting up the packet filters themselves, going in there and saying I want to allow this port through and this protocol to access my server. Now we'll also discover as we're doing this that packet filters aren't used for everything, or maybe not everything people think they are. There's also some publishing rules we'll discuss in this section too. We'll look at the options that you can configure with packet filtering. There's a screen full of attributes and options that we can set up for that. And then finally, we'll talk about something that is near and dear to my heart, the application filters. This is cool. Here's the problem. Packet filters are fine and dandy when it comes to blocking port numbers, but you know what? Port numbers are just that, port numbers. If an application changes its port number, what can you do to block it? Well, that's where these application filters can come in. And they can jump in and recognize the application themselves rather than just the port numbers. It's very cool stuff, but I'm getting ahead of myself. I just had to give you the tip of the iceberg on this one because it's such a cool concept. Well, let's not beat around the bush at all. I want to take you straight into the configuration of packet filtering and IP routing, the concepts we talked about in ISA Server Firewall Features Part 1. I'm going to expand the ISA Server configuration and hit the access policy. Now under here we have the IP packet filtering, but I'm not going to configure the packet filters yet. I'm going to just go to the properties. Inside of there, on this first screen, we see that packet filtering is enabled, and it is by default. Now just a little review. By enabling packet filtering, you instantly allow the ISA server to drop any access attempts on its external interface. And this is on by default. Any access attempts that are not responses to requests from internal clients. If all you have is internal clients going through the ISA server for internet access, this configuration right here is probably all you need. Now, skip this one for now. I'll come back to it. Hit Enable IP Routing. This is the one that enables the IP routing features of ISA server. Now remember again, there's two reasons why you might want IP routing. The first one is that you're routing between two or more publicly accessible subnets. And what I mean there is we have our internet connection and maybe a DMZ. And inside of that DMZ you have real IP addresses that are not using NAT to be translated. That would be a situation where you enable IP routing. And of course you want packet filtering on top of it because you want to be able to dictate exactly what traffic can get into that DMZ network. Notice that if you uncheck this, everything grays out. Because if you disable packet filtering, you're pretty much cutting off ISA server's ability to be a firewall. You might as well use Windows 2000 routing and remote access to do it from there on out. So these two features are enabled from this tab. Now you also see the Enable Intrusion Detection, and we're going to talk about that one in much more detail when we get to the monitoring and reporting nugget on ISA server. But in essence, that allows you to detect many of the common hacking attempts that occur on the ISA server and block them and notify the administrator that they are occurring. Now before we get into the creation of the packet filters themselves, let me hit a couple of the high points about why we use these. Here are the situations that require you to use those packet filters, and we're going to create these in just a moment. When you first install the ISA server, none of the services or applications that run on the ISA server itself will not work. We need to create packet filters for them. For example, I'm going to prove it to you in just a moment. We won't be able to even open a web browser and get to the websites because that's a service or application running on the ISA server. Packet filtering is also necessary to protect servers in the 3-home design because you're going to be routing between the internet and the DMZ. You need to protect them. Packet filters choose what ports are allowed. Finally, protocols other than TCP and UDP need to have specific packet filters created allowing them. Some of them are created by default, and I'll show those to you right now. The first thing I want to show you is the default packet filters that exist in the ISA management. Okay, a little beyond the default, but that's just because a few nuggets ago we ran the VPN creation wizard, and that allowed incoming VPN connections between our clients and our server and between two gateways that we set up. Check out the VPN nugget if you want to see more on that. That's what these first four are. Allow L2TP incoming and outgoing, and allow PPTP incoming and outgoing. Now you also see right here we have a DHCP client. This one is in there by default, and this is what allows your ISA server to receive a DHCP assigned address on its external interface. Now you also notice that this one has the little red arrow sitting by it. That means it's disabled. One of the cool things about these packet filters is you can create as many as you want, and they never take effect until you enable them. We do that by clicking this little green up arrow, and poof, our ISA server is now able to receive DHCP assigned addresses. Again, that is in there and disabled by default. You have the DNS filter. DNS filter allows ISA server to do DNS lookups on the external interface. So that way, when it needs to resolve yahoo.com for an internal client, it can do that. Down here we have a whole group of ICMP messages, and these are really good because they allow ping messages, these first two, pings going outbound and pings coming inbound. So somebody can ping the ISA server to test connectivity from the outside. We also have the source quench ICMP message, which is a great one because on the internet, servers might send the ISA server a source quench saying, whoa, slow down. You're sending too much information, and we don't want to drop it. This allows people to tell you to slow down. Down here you have a timeout message. This is if you have a routing loop, maybe somewhere on the internet. Somebody tries to access a site that is in the loop. Instead of going around for infinity and they never get a response, it will eventually hit the time to live, and the number of hops will be reached, and an ICMP timeout message will be returned to the ISA server letting them know it's unavailable. IP unreachable is very similar, or ICMP, I keep saying IP. ICMP unreachable is very similar in the sense that a server can tell you that something is unreachable out on the internet, and that's what that message is allowed for. Okay, this one I've got to admit wasn't created by default, but the ISA server that I'm working on right here is not local to me. It is actually at a remote office, so I created a packet filter called RDP. Stands for, as many of you may know, the Remote Desktop Protocol. You see, this is a custom filter, and it is allowing port 3389 on this ISA server. That allows me to remotely access this and show you what I'm showing you right now, hundreds of miles away. Now looking at this configuration right now, would this server be able to access the internet? If I opened the web browser, would it be able to browse the internet? The answer is no. The reason why is, well, it could perform DNS lookups, it could resolve yahoo.com to its IP address, but as of right now, there is no packet filter that allows HTTP access. Let me prove it to you. I'm going to open Internet Explorer, and we'll go ahead and go to cbtnuggets.com. When I hit enter, it's sitting here, and it's just going to wait. Eventually, this will time out. Now, there's going to be two ways to get around this. One is I could go in and make this browser use the web proxy service. Check this out. I'll go into Tools, hit Internet Options, Connections, LAN Settings, and I already have it typed in there from before, use a proxy server. I've got the address 127.0.0.1, which is a loopback address, pretty much meaning go to yourself on port 8080, which is the default. If I enable that, it will work. I can't access it through the web proxy service. However, that may not be what we want to do. Maybe we want the ISA server to have direct internet access, or maybe we need some other port opened that this web proxy service can't provide for. In that case, we're going to have to create a packet filter. Here's how that's going to happen. I'm going to open the ISA Management Console, right-click on the IP packet filters, hit New, Filter. Give it a nice logical name, and I'm going to say outgoing HTTP for ISA. The reason I say that is because if I just type HTTP, that could mean for some internal web server, so I want to make it real logical for myself. I'll hit Next. Now, this is asking me, do you want to set this for all the ISA servers in the array or only this server? This gets into the enterprise policies. We'll talk all about it in the enterprise strategy nuggets later on. But for now, I'm going to apply it to just this server, this ISA server. It's going to ask me, do you want this filter to allow or block packet transmission? Well, we've got HTTP. We'll want it to be allowed. Now, from here, it's going to say, what filter type would you like to use? Is it a predefined one like DNS lookup, ICMP? These are all the common protocols that we see out there. Now, be careful. You see this. You might think, oh, HTTP server, right? Yes, but this is going to be for HTTP servers either running on the ISA server or inside of your network. If you want HTTP going outbound, you're going to need to create that one as a custom filter. I'll click Custom. From here, it's going to ask me, what IP protocol do you want to use? Do you want any IP-based protocol to be used? ICMP, TCP, UDP, or a custom protocol? Now you might be thinking, what is a custom protocol? Well, believe it or not, there are actually protocol numbers at layer 4 of the OSI model that help identify specific protocols. For example, TCP, I believe, is protocol number 6. Yes, over here you see it, protocol 6. UDP is protocol 17. ICMP is protocol 1. There are also other protocols, like, for instance, routing protocols. OSPF works at the transport layer. EIGRP is another one that works at the transport layer. So if you wanted to allow routing packets to go through, you would have to create a custom protocol and type in their number. For now, we are allowing HTTP traffic, so we'll hit TCP. Now it's going to ask the direction. Is this coming in? Is this going out? Or is it both? In this case, we're not running an HTTP server, so I'm going to restrict this to outbound. From here, we have to define the local and remote ports. One of the most mind-boggling, confusing, mesmerizing concepts I've ever seen. I've got to show you this one on a whiteboard. Understanding how port numbers work, in my opinion, is one of the coolest parts of TCP/IP. I explain this to anyone who cares, even my wife. I sit on my whiteboard at home and try to get her to understand this because it's just such a neat concept. Most people know. First off, let's paint a scenario. Let's say we have this computer and it's running Internet Explorer. And Internet Explorer is going over to access, I will say this is Nabisco.com. They want to find out the nutrition facts on fig Newtons. So they open Internet Explorer and they access Nabisco.com. What port number do they use? Well, you might know that when you're going to a web server, HTTP is always going to use port 80. Now, when you get to the web server, what does that port number say? Well, it says, I need to access the application that is answering to port 80. And thankfully, Nabisco.com and any other web server out there is configured to answer port 80, the well-known port number for web services. But here's the dilemma. When I opened Internet Explorer on my computer, it was one of probably many applications that I have open. I might have an Internet Explorer instance going to Nabisco, one going to CNN.com, one going to CBT Nuggets. I might even have some FTP applications open. And since we only have one network card or modem coming in, we're receiving data for all of those applications through that one. How does this computer know which application should get what data? Well, there's actually a local port as well. See, when we accessed the web server, we accessed it on the remote port of 80. But when we opened Internet Explorer, it will dynamically generate its own port number, and it will be somewhere in the range of 1025 through 5000. Here's the magic that happens. We open this Internet Explorer instance, and it says IE is going to be, oh, we'll just say 3152. They're randomly chosen, dynamically generated. So we go out to Nabisco.com on port 80. So Nabisco.com, you can almost think of it as :80. Now when Nabisco.com sends back to us, they will be communicating with our IP address. We'll say it's 130.1.1.1. Then they will be sending it to, you've got it, port 3152. That way, when our computer receives it, it goes, oh, you're going to the Internet Explorer instance that wants the Nabisco.com information. Matter of fact, you're actually able to see all these port numbers that are open on your computer for every single application that you open. Let me show that to you. You've got to check this out. I'm going to go ahead and open up a command prompt. Actually, I'm going to open up plenty of them. The reason why is I'm going to create multiple sessions of FTP. I'm going to say FTP to ftp.cisco.com and open FTP sessions in each one of these. ftp.cisco.com. Come over here, ftp.cisco.com. You see in the background some of them are connecting. There we've got a connection. I'm opening 4 different FTP sessions. So essentially I have 4 different applications running on this ISA server. Now watch this. I'll open one more command prompt, and this is the command that you'll use. It's a very handy one. Net stat. Enter. Instantly, I'm able to see all the different addresses and ports that are open on my computer. Look at this information that we get. It's so valuable. We've got the TCP protocol being used. The local address is our host name, ISA-server:3090. The foreign address is ftp-sj, I'm assuming sanjose.cisco.com, :FTP, because that's a well-known port number. Notice for every single one of those command prompts that I opened up, I see the local dynamically generated address. All these FTP servers, it's probably only one, but all these FTP instances are communicating back to each one of these unique port numbers, which takes it to each one of these unique windows sitting here in the background. That's how the local dynamic ports work. Now let's get back to the packet filters on our I'm thinking Cisco router. It's our ISA server. I'm going to go back into the configuration and hit New Filter. I had to close it down just to make way for those command prompts. Again, I'll choose TCP outbound. Now here's the question we left off at. Local port and remote port. Well, now we've got to think about it. This is why I said it can be so mind-boggling. We are the ISA server. We are wanting to go outbound to access other websites. So we are accessing the remote port of port 80. But what's our local port going to be? Well, thankfully, they give us one for dynamic. They realize that we're going to have dynamically generated ports, and instantly when we select this, it will allow the ports 1025 through 5000. See, we have the ability to restrict access both on the local port and the remote port. So now that we've done that, I'll hit Next. It says, what do you want to apply this to? Do you want to apply it to the default IP address for each external interface, so any external interfaces, this individual external IP address, or this computer somewhere out on the perimeter network, and mainly talking about the DMZ in that case. For now, I'll just say all the external interfaces. Whatever one I go out, I need HTTP access. Do you want them to have access to all the remote computers or just this one? Well, it's a big internet out there, folks. I'm going to choose all remote computers. I'll hit Finish, and I have now created the rule HTTP outbound. Here is a tip for you. When you create packet filters or protocol rules or site and content rules, one thing that you may find, and I have found it especially with packet filters, is that there's about a minute delay before they take effect. As in, if I open a web browser right now and go, I'll probably still be blocked. Microsoft knows about this. They've documented on their website. It's just a known fact that it takes some time for this to take effect. So I'm going to pause the recording while this takes effect, and I'll come back and we'll test this outbound access. Okay, I've waited a minute for the packet filter to take effect, and let's go ahead and test this out. I'm going to open Internet Explorer, and let's go to a website that I haven't been to before so I can make sure that it's not cached. And before I do, what I want to do is I want to show you that I'm not using the proxy server. This is going straight through the packet filter. I do not have the web browser directed to the ISA server as a proxy server. I'm going to go ahead and click OK, hit OK, and let's go to Nabisco.com, right? The example that we used before. I'll just type in Nabisco. Control Enter. And hopefully there is a Nabisco. Sure enough, there is. NabiscoWorld.com. You too could win a trip to New York City plus spending money by voting on Oreo cookies. So this proves that the packet filtering is taking effect. Otherwise, this would come back as page not found. Now, while we're doing this, let me show you something. I'm going to open a command prompt and type in netstat. Here is there's actually connections, but multiple connections. Why? Well, that web page might have some dynamic content or might make some calls that have it open multiple HTTP sessions. And what we see here is that the foreign address is nabisco.com on HTTP, and the local address is on the ISIS server, port 3054, 55, and 56. All of these ports have been opened dynamically. And in my mind, that is the toughest part of creating these packet filters, is keeping in mind which direction and what port numbers are being opened. For example, I'm coming to this filter type, and the local port right here has to be dynamic. Why? Because when I just took you to that command prompt, you saw it opened locally port 3000 something, 3000 something plus 1 and plus 2 to allow that content to come back to the local server. The remote port was a fixed port on port number 80. That's the Nabisco web server that we're reaching. Now that's not too bad, but when you're publishing or you're allowing access to internal web servers in the DMZ or maybe even located on this ISIS server, that's where it just gets confusing, because the direction is going to flip on you. The remote port is going to become dynamic. We don't know what port number they're using out there. The local port becomes port 80. It becomes a mind boggler. So in my mind, that is the toughest part of configuring those packet filters to allow access. Before we leave packet filtering, let me show you the options that you can set dealing with packet filters. I'll go to the properties and hit packet filters, and we have three options here. One is the enable filtering of IP fragments. Fragments are pretty much chopped up pieces of Ethernet frames, and it happens sometimes where when you go through a router, they fragment it, and there's a whole variety of reasons of why that occurs. Now, there's also some denial of service attacks and worm attacks that have to deal with IP fragments. Pretty much as the ISA server puts together the packet with all the fragments, it's putting together its own little self-destruction bomb. So if you are sure you're not going to get IP fragments, you can check this and disable those from being received on the external interface. However, with the emergence of voice over IP and a lot of the audio streaming applications, IP fragments are becoming more and more and more common. Matter of fact, voice over IP, all it sends is IP fragments. So if you have any of those traffic types, definitely keep this one unchecked. Enable filtering of IP options. IP options are actually inside of the header of the frame, and this allows you to customize the IP packet. Some custom applications use this. Most of the time, unless you have a specific reason for doing so, it's safe to turn this one on, because there's many attacks that have IP options in the header. That's one of the attack types that are out there. So that's a good one to enable. Log packets from allow filters. Unless you have a very specific reason for doing this, I really wouldn't recommend it. What this would do is log every single packet that goes through the ISA server, both the denied attempts and the allowed ones. By enabling this, you will get a ton of information in your log files. Not only eats up hard drive and server performance, but it's just a ton of information to weed through. Like I said, I really wouldn't recommend turning this one on. There's one more tab that we'll deal with now. This intrusion detection tab we'll get to when we start talking about the monitoring and reporting. But PPTP, if you didn't use ISA server to set up your VPNs, this allows you to create a quick ISA filter or a packet filter to allow PPTP attempts through. By checking that, you can see right here, it created the SecureNet PPTP, which allows, let me scroll over, it allows anybody to access ISA server using a PPTP call, port 47, both directions, from any remote computer. So overall, this one will create a packet filter for you to accept and send PPTP requests from the ISA server. Now let's turn our attention from beyond the standard IP packet filters to something a little more called application filters. I'm going to expand the extensions, and right here we have application filters. These filters are powerful because they look beyond port numbers. They actually tap right into the application layer data and allow your ISA server to do a variety of things. Furthermore, they're very expandable. Matter of fact, let's make some good use of that web filter that we just created. And I'm going to take you to isaserver.org. At isaserver.org, one of the things that you'll find is software. And underneath there, I'll just go under Access Control, you'll find a ton of stuff that makes your ISA server customizable. Okay, yeah, most of it you will have to purchase, and they're demo versions of. But right here you have a web filter that is built from the ground up and defines 50 predefined categories and flexibility to create and customize your own web filtering. Pure Site, which allows you to do content filtering, so filter based on content. All these different plugins are different application filters that you can add to add functionality to your ISA server. And these are just the ones that are considered access control. If we look back over here, look at all these different categories of tools that we have. Most of these come in the form of an application filter. In this list of application filters, we have quite a few of them, and I want to take them one at a time. Some of them are modifiable, some of them are not, but all of them add some sort of functionality to your ISA server. Let's start off with the DNS intrusion detection filter. I'll open this up, and what you see is this filter is for guarding against attacks on your internal DNS servers. What attacks? Well, click on attacks, and you see that we have the host name overflow, the length overflow, transfers from privileged ports or high ports. These are commonly known DNS attacks. Now, the great thing about this filter is it's an application filter, so it's looking at the application data. You can't track a DNS attack by looking at port numbers. You have to verify host name information, verify length of packets, and see trends. That's what this application filter is here to do. Now we see the FTP access filter, and this one will make us realize that not all of these filters have properties. When I open it up, all you see is a general tab, and it says enables FTP protocols. The reason this is here is FTP is not like normal applications. It actually requires multiple port numbers on the fly. Here's what happens. You generate an outgoing FTP request, right? And it's accessing an external server on port 21. What's going to happen is that external server is going to start replying and sending control message back to you on port 20. Now, how's the ISA server supposed to know that? Well, this is going to be an application filter that watches for those access attempts, and as soon as it sees one of them, it will open up the return port of 20 for all the return traffic to your client. Moving on to the H.323 filter, you receive an application filter here that's able to control a lot of the H.323 properties that go on your network. Now, I haven't seen many people in the real world use this one, but I guarantee you, the more voice and video stream that we have going on, voice over IP, one of the big new applications that's hitting businesses today, the more you're going to see of this filter. What it does is it allows you to control your H.323 activity inside of your network. And when I say this, I mean opening an application like Microsoft NetMeeting and starting audio and video conferences with other people. The first thing you have is the ability to use a gatekeeper. A gatekeeper is kind of like an overlord of the H.323 network who dictates what calls can be made where, and it's a giant, kind of like a phone book for all the H.323 clients that it manages. There's another CBT nugget that is part of the ISA series that we'll talk about this in, the H.323 gatekeeper. ISA server can be a gatekeeper, and all we need to do is check this box and point it to the server that is going to be the gatekeeper. Then, when this ISA server receives H.323 calls, it will direct it to this gatekeeper that we specify here to manage the calls. We also have the ability to allow or deny incoming or outgoing calls. Notice we can also use to check this box to use DNS lookup to find H.323 clients. This is great because it allows you to say, well, I want people to be able to make calls, but maybe not receive calls from the internet. Here's my prediction. In the future, you know how we have email spam nowadays? Eventually we're going to have H.323 spam, and we're going to have like junk calls or telemarketer voice over IP calls. So that might be something that you want to do. Media control gives you the ability to control what your clients can use: audio, video, or T120 in application sharing. This is for whiteboarding applications. For example, NetMeeting includes whiteboarding and the ability to share your desktop and show people what are going on your desktop. There's many other applications that can use this. So overall, you get to choose what you want to allow your internal clients to use, all done with this H323 application filter. The HTTP redirection filter is the application filter that allows you to use caching with your firewall and secure NAT clients. Now, I know most of you are like, well, I thought it just did that anyway. Well, it does, but this is the application filter that does it. Here's what happens. When ISA-Server receives an HTTP request, a web server request, from one of your secure NAT or firewall clients, what it has the ability to do is one of three different things. What it does by default is redirect the request to the local web proxy service. That's the service in the ISA server that handles all the caching. So what happens is the ISA server gets the request and says, oh, before I send that to the internet, let me forward this to the web proxy service and have it check and see if that's in the cache already. Now, we also have this checkbox that says if the local service is unavailable, you can bypass it and redirect requests straight to the web server. You don't have to go through the web proxy service, which acts as kind of the intermediary between your internal clients and the internet. You also have the ability to bypass, I don't recommend it, but you could bypass the web proxy service and go straight to the outside web server. This pretty much negates all the caching functionality and a lot of the security features that ISA server gives your internal clients. And then you could do this one. Downright reject the request from any firewall or secure NAT clients. This is used for making sure that the people that are accessing the internet are configured to do so through the web proxy service. If you check this box, you better make sure, if you want web requests to be allowed, that you configure each internal web browser to support the web proxy configuration, going straight to the web proxy service. But that's what the HTTP redirector application filter does for you. The next two application filters in the list, the POP and RPC filter, are really just flybys. There's no properties for them. This one just watches for POP intrusion detection attacks, and this is really just POP buffer overflows. There's a common attacks on POP email servers that overflow their buffers. This one watches for it and prevents it. The RPC filter allows you to publish internal RPC servers. RPC stands for the remote procedure calls, and what it is it's a message passing algorithm that allows you to have distributed applications calling services available on various computers on your network. That didn't sound confusing, right? Overall, what this does is lets you have, for example, remote administration. That allows you to open an application on a client computer somewhere and administer a server internal to the network. That's just one application of RPC, but there's many other applications that use a distributed architecture and allows you to have various components across it. This filter allows you to publish those servers. But that's not the best one of them all. The best one of them all is SMTP filter, in my opinion, my humble opinion. Overall, SMTP filters allow you to filter your email traffic, just like it sounds. Notice that this is the only one that's disabled by default because, hey, ISA server doesn't know if you're running an internal Exchange server. Check this out. I'm going to open this up and look at how many options we have. This allows you to filter, just like it says, email traffic. If you want to turn it on, just check the box. Here's what it allows you to do. First off, it lets you filter based on keywords. For example, if I receive an email that says, I'm trying to think of all the spam ones, but of course all the inappropriate ones are coming to mind because that seems to be all I get. How about credit card? If I receive an email that has credit card in it, in the message header or the body, I want to filter it out. Okay? This allows you to go ahead and define filters that catch the emails before they even reach your internal servers. And you have the option of what you want to do at the bottom. Do you want to delete the message, hold the message, or maybe forward the message to some email address that's meant to get the spam messages in your company? This allows you to define, just based on keywords, filters that blocks certain emails. Now we also have this users/domains tab. What this does is allows you to filter based on the username, the sender name, or a given domain. For example, if you're receiving a lot of spam message from maybe hotmail.com, you can go ahead and choose to add that to your rejected domains. Now, anytime the ISO server receives an email from Hotmail, it will block it. Maybe you even want to get more specific than that, and I want to say, you know, anytime that there's the sender v1GRA, okay, I want to add that to the rejected senders because maybe you're getting a lot of email from some sender that has the name v1GRA. That's the idea of the Users and Domains tab. Just as the name implies, the Attachment tab filters out the attachments and allows you to customize what attachments you want to receive. For example, let's say that there's a new virus attack, you know, a worm or something that's being sent in the email. Maybe it's pretty obvious, and the attachment name is worm.vbs. Okay, we can go ahead and enable an attachment rule that says, I want to filter and delete any emails that have an attachment that has worm.vbs in the list. Now, maybe you don't want any Visual Basic scripts or any exe files to be received. You could also type that in as the attachment extension. Now, anytime you receive an extension with the VBS, it will go ahead and filter that out. Now, the final one is the attachment size limits. Companies may want to start doing this because I'll tell you what, you know those forwards that go around, they just seem to keep getting bigger and bigger. There's not a day that goes by that I don't get an attachment that's larger than 1 megabyte in size from a relative of mine thinking that it's funny, and sometimes they are. But you can go ahead and filter it based on the bytes so you don't eat up all the space on your Exchange server. Again, you have the same actions that you can do: delete, hold the message, or forward the message to a certain person in your company. The final way that you can filter your email messages is by going to the SMTP commands. This isn't so much for filtering emails as it is for protecting your internal email server. There's many attacks that try to compromise an email server by doing buffer overflows, by sending certain commands that the email server wasn't expecting that are sized differently. So what this does is it allows you to create all the commands, and these are in there by default, and it allows you to specify the commands that the email server will accept and how long the maximum length that message should be. For example, we have the bdat command, and that is a maximum of 20 bytes in length. It just sounded funny. Overall, you can specify, these are again in there by default, but you could add your own commands that you will expect to see sent to your email server and how long maximum they can be in length. Now, just as a sidebar, in order to use this filter and to filter by keywords, users and domains, or by attachments, you need to make sure that you include the message screener service during your ISO server install. We're going to talk about this a lot more in a later nugget when we talk about publishing your internal servers, but the message screener service allows you to screen the actual email messages and open an email before you send it to the internal email server. That's going to be covered, as I mentioned, in the publishing internal servers nugget. So that's the SMTP filter. In the list, we also have the SOX filter. SOX is an application protocol that was developed for communication between client and server applications. And the way it was designed is that the client and the server would never have direct contact with each other and direct IP reachability. It was kind of a predecessor to a proxy server. Now, some applications still use SOX, and the ISO server can support SOX version 4 communication between those client and server applications if you happen to have one of those applications. The only thing you need to configure is what port the SOX v4 request will be received from the client application. Now, by default, it's going to be 1080. If the application requires something else, you can change it on here. However, all the applications need to share that same port number because we only have one SOX version 4 filter and it can only receive on a single port number. The final filter that we have is called the streaming media filter, and it's pretty cool. You know what streaming media is, right? Where you go out to the internet and you're starting to stream audio from the internet. Now, all that audio isn't directly on your computer, right? It kind of buffers it from the internet and starts playing it once it receives enough of its buffer. Well, the streaming media filter takes that one step further. What it allows you to do is something called live stream splitting. Now, by default, this is disabled, even though the application filter itself is enabled. What live stream splitting does is it allows you to download, as the audio stream or video stream or whatever sort of stream is coming through the ISA server, it allows you to cache that stream and then kind of restream it from your local server. The reason this is great is because if you have like 2 clients in your network that are all tuned in, or that are tuned into the same audio stream, you've just cut your bandwidth requirements in half. If you have 3 people tuned into the same audio stream, you've cut it by a third. It allows you to locally cache live audio streams and send it out to those clients. I've seen so many businesses that I've walked into that people open up, just a standard audio streamer to their favorite radio station using real audio or something like that. It's great. They get tunes all day, but just think of that as taking your WAN bandwidth, your internet connection, taking one large slice out of it and reserving it for that person, because that's exactly what happens. So with this, we have the option. We can split the live streams using a local Windows Media Technology server. That means that this ISA server is also a Windows Media Technology server. How do you make it one? Well, have you ever been going through the Windows 2000 or 2003 install, and you get to the optional components screen, and one of the options is the Windows Media Services? That's what you need to install. You need to make sure that this is a Windows Media server so it can support those streams. It can cache them using that server and then restream them to the internal clients. If you have an ISA server array, which we'll talk about in the enterprise strategy nugget, you can actually add multiple ISA servers to this to distribute the load, because it can get pretty intense at times. I can just go ahead and click on add and add all the internal ISA servers that maybe are participating in the stream, and then what user account I'm going to use to connect when I'm reaching those servers. Now, if you're part of a domain and you have the same user account that accesses all of them, you don't really need to worry about this. But if you don't, then you can type in the user account that you use on that server. That's the idea of the streaming media properties, and that's the overall idea of the application filters. They take it one step further, and I think by now you should have kind of a good idea of what the future could hold for ISA server with how expandable these are, since Microsoft has allowed many third-party vendors to start writing their own plugins for the application filters. Good stuff. What you have seen in this nugget is, first off, configuring packet filtering and IP routing. We talked about the concepts in ISA Server Firewalls Part 1, and in here we actually showed how you configure those options. The second thing we did was create the IP packet filters, allowing access to services and applications running on the ISA server and services and applications located in our DMZ. We also set up the packet filtering options, which focus primarily on security, watching for those IP packet fragments, intrusion detection, things like that. Finally, we talked about one of the most potentially expandable areas of ISA server, and that is the application filters, which looks beyond the port numbers into the application layer data. I hope this has been informative for you, and I'd like to thank you for viewing.